Alright, in this second video in which we deal with polynomial division, we'll be talking about the remainder theorem and the factor theorem. So notice the remainder theorem here says if the polynomial f of x is divided by x minus c, then the remainder is f of c. So I'm going to go ahead and illustrate this to you with an example, and you can see that this works, and it works for all polynomials. So in example 4, we had the polynomial x cubed minus 7x minus 4. That was on the previous page. And we divided by x plus 2. So notice here, this is of the form x minus c, where c would be negative 2. So we have exactly the condition here. If the polynomial, this is our f, is divided by x minus c, in our case it's x plus 2, then the claim is that the remainder will be f of c, or in our case, the remainder is going to equal f of negative 2. Well, let's see why this is true. When we did the division, we got an answer of x squared minus 2x minus 3 plus 2 over x plus 2. In fact, our remainder was 2. And so that tells us that f of negative 2 is 2, according to this remainder theorem. Well, let's see why that's true. Well, we had also said that we could check our answer. X cubed minus 7x minus 4 should equal our divisor times the quotient that we got, or the answer, plus the remainder. This actually gives us an alternative way to write this polynomial. So that's what I'm going to do here. I'm going to rewrite x cubed minus 7x minus 4 in a different way. This product plus 2 should equal that. And in fact it does, so it gives us another way to write the polynomial. Well, now we can see that if we plug in negative 2, remember f of negative 2 should equal 2. Let's do that here. So notice what happens here. We've got negative 2 plus 2. Well, that's 0. And we're multiplying 0 by all of that, and all of that is going to be 0. And 0 plus 2 is 2. And so you can see that it works. And the key is, this is always going to zero out no matter what your x minus c is. All right, so let's go ahead and use this for example 1 and 2. Notice it says use synthetic division and the remainder theorem to find the function value. So for f of x equals x cubed minus 6x squared plus 11x minus 6, we're supposed to find f of negative 2. Now keep in mind, we could just plug in negative 2 and get an answer, but we've been asked to use synthetic division and the remainder theorem. So what does that say? So the remainder theorem is telling us, first of all, in this case here, our f of c, or in this case c, is negative 2. So by the remainder theorem, x minus c, or in this case x minus negative 2, when we divide the polynomial by that, the remainder we get is going to equal f of negative 2. Well, let's write this as x plus 2. So when we divide this polynomial by x minus 2, using synthetic division, we'll put the negative 2 in the box. Now notice, you could either think of that number as our c value, or we know if we're dividing by x plus 2, we use a negative 2. Alright, so let's put our coefficients in there and do synthetic division. So we'll drop our 1, and then we'll do our multiply add here. So we're going to multiply 1 and negative 2 to get negative 2. When we add here, we get negative 8. Excuse me. Negative 2 times negative 8 is 16, and when we add, we get 27. Multiply negative 2 times 27, you get negative 54, and when we add, we get negative 60. And so f of negative 2, by the remainder theorem, is equal to negative 60. So I would encourage you to try example 2 and see if you can do the same thing I just did here, or you can just watch the video. Alright, so let's see how you did if you tried to do that. In this problem, c is 3. So when we divide by x minus 3, whatever we get as a remainder should equal h of 3. Well, again, so 3 goes in the box. Notice here we are missing our x to the 4th term and also our x term. So we'll need zeros in those spots. So we're going to have 2, 0, negative 10, negative 19, 0, and negative 50. And let's go ahead and drop our 2 and do multiplication first. So 2 times 3 is 6. When we add here, we get 6. Multiply, you get 18. When you add there, you get 8. Multiply 3 and 8, you get 24. And when you add, you get 5. 5 times 3 is 15. And when you add, you get 15. 15 times 3 is 45. And when you add, you get negative 5. And so here, h of 3 is equal to negative 5. Now, I told you you can't just plug the number into the function to evaluate it, but you could certainly check it if for some reason you weren't comfortable that you had the right answer. So I'll just make a note of that. We can check answer by plugging in 3 into the function h. So that's what I was doing there. All right. So the other theorem we have is what we call the factor theorem, and really this is the really important one. This is one we're going to be using a lot. It says x minus c is a factor of the polynomial f of x if and only if f of c equals 0. Now with an if and only if statement, it's true in both directions, so we will go back in, well, we will go in both directions. So I'm going to refer you back to example 1. And we learned in example 1 that x minus 3 was a factor of f of x equals x squared minus 8x plus 15. In fact, we divided x squared minus 8x plus 15 by x minus 3, and I think we got x minus 5. So this is our condition here if we're going from left to right. We have x minus 3 is a factor of f of x, and this is our f of x, x squared minus 8x plus 15. So what the theorem is saying, now notice in this problem our c is 3. So what the theorem is saying is that f of 3 is equal to 0. Well, by the remainder theorem, we know that f of 3 will equal the remainder when we do division by x minus 3 with this polynomial. But when we did the division, we got 0 for a remainder. And so we can see, or we know, that f of 3 does equal 0. Now, if we, well, and actually, let me show you one more thing. We could actually write f of x in its factored form, x minus 3 times x minus 5. And if you plug in 3, you get 3 minus 3 times 3 minus 5. And of course, 3 minus 3 is 0, and so we're going to get 0 when we multiply there. And so you can see that that's true. Now, and if we go the other direction, it says here f of c equals 0. Well, if that's true, we know that x minus 3 is a factor. That's something we've learned previously. Well, we now have what we were trying to prove. X minus c is a factor of the polynomial. And so we're done with going that direction. So let's go ahead and use the factor theorem now. On number 1 here it says, is x minus 2 a factor of x squared minus 5x plus 6? Well, by the factor theorem we know it is if we do the division and we get a remainder of 0. So let's go ahead and do this. So we put a 2 in our box. We're going to use 1, negative 5, and 6. So drop the 1. 1 times 2 is 2. When you add negative 5 and 2, you get negative 3. Negative 3 times 2 is negative 6. When you add, you get 0. And so the answer here is yes. It is a factor because we got a remainder of 0. In fact, our answer would be x minus 3. On number 2, actually, let me go back just a little bit. So if we actually had to find the answer, it was x minus 3. But the question was, is x minus 2 a factor? And the answer is, yes, it is a factor. So you may want to try number 2, and then you can check the answer that I give. All right, so let's do this. We're going to put a negative 5 in the box since we have a plus 5 here. And don't forget, you do have a missing term there, so you will need a 0 for the x term. So let's drop our 1, and 1 times negative 5 is negative 5. When we add negative 5 and 2, we get negative 3. Negative 3 times negative 5 is 15. When we add, we get 15. We always add in columns, right? 15 times negative 5 is negative 75, and we are definitely not going to get 0 here. We get negative 81. And so the answer here is no. Now, number 3, it says factor f completely if x plus 3 is a factor of 6x cubed plus 19x squared plus 2x minus 3. Now, I want to show you something here. We're supposed to factor this completely, and we currently only have one technique that we could use to do this. We could factor out an x squared here times 6x plus 19. But when we factor here, we're not going to get a 6x plus 19. So factoring by grouping is not an option. It's not going to work here. And so what we're about to do is going to help us factor something that we previously couldn't. So by the remainder theorem, if x plus 3 is a factor, when we do the division, we should get a remainder of 0. So let's use synthetic division. So negative 3 goes in the box, and we're not missing any terms here. So it's going to be 6 times negative 3, which is negative 18, plus 19 is 1, times negative 3 is negative 3. When we add negative 3 and 2, we get negative 1. And negative 1 times negative 3 is 3. So we do get a remainder of 0, which is exactly what we expect, because this is a factor. X plus 3 is a factor, and by the factor theorem, we should get a remainder of 0. So the cool thing now is we can write this polynomial as x plus 3 times the answer we got. Now remember, this was 6x cubed, and so we're going to have to drop our degree by 1. That'll be 6x squared plus x minus 1. And now notice the 6x squared plus x minus 1. This is quadratic, and it's trinomial, so we should try to factor this using the AC method. So we need two numbers that multiply to negative 6 and add up to 1. Well, the numbers that work here are negative 2 and 3. Notice negative 2 times 3 is negative 6, and negative 2 plus 3 is 1. And so notice I can't take the shortcut here because that's not a 1. And so I split my b term. The 1x becomes a minus 2x plus 3x. We're just using the numbers we got here. And now we'll factor by grouping. So for those two terms, our GCF is 2x times 3x minus 1. So when we factor here, we expect to get a 3x minus 1. That's interesting. This would have to be a plus 1 to make that work. And so we get 3x minus 1 times 2x plus 1. Now don't forget, we're in the middle of factoring our function fx. So the final factorization is x plus 3 times 3x minus 1 times 2x plus 1. Now I could have asked the question a little differently here. This is our answer here. We were asked to factor this completely. We could have been asked to find the zeros of the function. If that were the case, we would have set each of our factors equal to 0, and that would give us the zeros. But in this problem, we're done. Let's move on to number, what should say 4. So in this problem, we're solving this equation here. But notice we've been given a 0 of, basically, notice this is just the polynomial function that has the same polynomial in it. And so if negative 1 is a 0 of this function, we know that x plus 1 is a factor of this function. And so we can use synthetic division with negative 1, and we should get a remainder of 0. And again, notice there's no zeros to put in here because we have x squared, then x cubed, then x squared, then x, then the constant. No missing terms. So let's drop the 15. So multiply, add, multiply, add, multiply, and add. We do get 0. And again, we can write this as f of x equals x plus 1, what we were dividing by, times our answer. Again, drop your degree by 1. We're going from x cubed to x squared. So 15x squared minus 1x, or just minus x, minus 2. This is very similar to the last one we did. We can factor this. We need two numbers that multiply to negative 30 and add to negative 1. That's going to be 5 and 6. And let's see, the bigger number needs to be negative, so notice 5 times negative 6 does give you negative 30, and 5 plus negative 6 does give you negative 1. So we can split our b term, and let's factor by grouping. Our GCF here is 5x times 3x plus 1. And if we factor there, we should also get a 3x plus 1. Since that's a minus 6x, it's going to need to be a negative 2 there. And notice, so negative 2 times 3x is the negative 6x, and negative 2 times 1 gives us the negative 2. So that does work. And so we do get 3x plus 1 times 5x minus 2. All right, so don't forget where we're at here. We're factoring this function. Now keep in mind, if we were trying to find the zeros of the function, we've just set these factors equal to 0. And actually what we're about to do is pretty much the same. Notice we're solving this equation over here. So let's write it in factored form. And if we're solving it, we're just setting each of our factors equal to 0. Of course, we knew negative 1 was a 0. And here, if we subtract 1 and then divide by 3, we'll get negative 1/3. And the last one there, we're going to add 2 to both sides. And then divide by 5, and we get 2/5. So those are the three solutions to this equation. So keep in mind, I could have asked this question a few different ways. I could have said solve this equation, which is what we had to do here. Or I could have asked you to just factor that completely. Or I could ask you to give me the zeros of that function. So there's 3 different ways you'll see those questions asked. All right, and that's it for this video.